Today we're going to be talking about congruence and triangles. Our objective, we will be able to identify congruent figures and corresponding parts. So the first goal of today, are the following figures congruent? And we've got triangle ABC here and triangle TON. In order to answer that, we need to know that congruent figures have the same size and the same shape. So each corresponding part a pair of angles or sides that have the same relative position in two congruent figures must be equal. If they are, we can describe them with a congruence statement. So if we look here, angle A is 41 degrees. Angle N is also 41 degrees, so they are congruent. Angle B is 58 degrees. So is angle T, so they are congruent. Angle C and angle O are also congruent. Notice how with all the angles, I'm putting the angle symbol. What about the sides? Well, if I look at side AC, that is congruent to side NO. Side OT is the same as CB. And then finally, BA is the same as TN. Since all the angles match up with a congruent statement and all the sides match up with a congruent statement, therefore, we know that triangle ABC is congruent to triangle. Now, when we write the letters for the first triangle, we're not too concerned about the order. When we write the letters for the second triangle, we need to make sure that the parts that are congruent line up. So since angle A and angle N are congruent, since A was first here, N needs to be first in the congruent statement. B was congruent to T, so T will come second. And C was third, and it's congruent to angle O, so O will come third. Let's look at a picture where we're not given any measurements. We're just given symbols. We know that angle D is congruent to angle H by their markings. We also know that angle G is congruent to angle F. Are these angles congruent? Yes, they are, because they are vertical angles. And we know vertical angles are always the same. So I'm going to use 3 letters to represent this angle because otherwise they'd both be angle E. So angle DEG is congruent to angle HEF. What about the sides? Side DG has one tick mark, and so does side HF, so they are congruent. Our markings also tell us that DE is congruent to HE. And finally, EF is congruent to EG. So we know triangle DGE is congruent to triangle HFE. Notice D and H are the same place, G and F, E and E. DG are the first two letters in our first triangle, and HE are the first two letters in our second triangle. DE is first and last, HE first and last. So the order that you write your letters in your congruence statement are very important. Next, are these two triangles congruent? Their angles are all the same. The sides in triangle NMP are all congruent to each other, and the sides in angle TQR are all congruent to each other. But since the sides in NMP are not congruent to the sides in TQR, these triangles are not congruent because the sides are not congruent. This time, we're given that triangle ABC is congruent to triangle FGH, and they want us to find the value of x and y. So x is over here on side FG. FG are the first two letters in our triangle congruence statement. So that means that FG has to be congruent to AB, which we know is 5. So x plus 1 must equal 5. So if we solve that, x must equal 4. Now what about for y? Y is up here in angle F. Well, angle F matches up with angle A, so we know that 2y has to equal 46. Divide both sides by 2, and we get that y equals 23. Let's move on to our next theorem. Given the following figures, what is the value of x? So we're looking for this angle down here. In order to solve, we need the third angles theorem, which states if two angles in a triangle are congruent to two angles in another triangle, then the third angles in the triangles are also congruent. By our markings, we know angle A is congruent to angle N, so angle N must be 30. We know angle C and angle O are congruent, so they're both 110. So we know that 30 plus 110 plus x adds up to 180, because the angles of a triangle always add up to 180. So if we simplify and solve, we know that x must be 40 degrees. What about with triangles DKM and FMT? By the markings, we know angle F and angle K are congruent. We also know that these angles are vertical angles, so they're congruent. So that must mean that our third angles are also congruent, which tells us that x equals 65 degrees. Next, we're going to look at some properties. Our first property is the reflexive property of congruence. Now let's say this triangle A, B, C is bisected by the line segment BD. So that means we have one triangle over here, ABD, and we have another triangle over here, BCD. Since they share this side BD, we know that BD of triangle BAD is congruent to the BD and triangle BDC. The symmetric property of congruence, I'm going to leave some space to write the definition, but I'm going to draw some triangles down here as well. We have A, B, C, and D, E, F. If we know that AC is congruent to DF, then we could also say that DF is congruent to AC. So the order we write them in our congruence, as in which triangle comes first, or the parts from which triangle come first, doesn't matter. And then finally, the transitive property of congruence. if AB is congruent to CD, which we know from their markings, and we know that CD equals 5 because that's labeled, then we also know that AB also equals 5. Basically, what we did here is we cut out the middleman. This should sound familiar. It's very similar to the law of syllogism, which we learned back in Unit 1. So let's see how the third angle theorem and these three properties of congruence can help us. We're also going to use some previous information that we already knew. So none of these angles are marked, and we need to know that all the sides and all the angles are congruent in order to say the triangles are congruent. We know that angle Y, these are vertical angles, so we know they will be congruent. What do these little triangles on the lines mean? They mean that this side, BN, is parallel to this side, GH. And then JN is the transversal that touches both of them. That means that angle J and angle N are congruent because they are alternate interior angles. JH and BN also have a transversal of BH. So that means that these angles are also congruent because they are alternate interior angles. So let's write our congruence statement. Angle J, I'm going to start there, HY, or triangle, JHY, is congruent. Now, angle J had 2 marks, so I know the first letter for my second triangle has to be congruent to J, which was N. I used H second, which had 3 marks, which means angle B comes next. And then finally, Y. The order that you write these letters in doesn't matter as long as they match up from the first triangle to the second triangle. So I started with J. I could have also started with H. H goes with B. Then gone to Y. And then on to J, which would make B, then Y, then N. Either one is an acceptable answer. So let's look at triangles LKS and triangle QPA. I know that all the sides match up. I know that 2 of the angles are congruent to each other, which means angle S and angle Q are congruent due to the third angle theorem. So therefore, I can say triangle S, start with S there, use my congruent angles. I'll have to start with Q, then K. K has 2 congruence marks, so A would be next in my other triangle, and finally L and P. So triangle SKL is congruent to triangle QAP. Now let's write our summary. Use your own words to describe what it means for figures to be congruent. Also, where outside of the classroom do we see congruent figures? Write your summary, and we'll see you in class.